Good day, grade 11 students of Kawayan City National High School. For today's video lesson, we will compute for the length of the confidence interval. To start, let's define the length of confidence interval. The length of confidence interval, or L, is the difference between the upper limit and the lower limit of the interval estimate. We have the formula L is equal to upper limit minus lower limit. Other formula, L is equal to 2 multiplied to the quantity of z alpha half multiplied to sigma divided by the square root of n for the confidence interval of the unknown population mean and known standard deviation, or L is equal to 2 multiplied to the quantity of t sub alpha half and n minus 1 times sigma all over square root of n for the confidence interval of the unknown population mean and unknown standard deviation. Let's have the steps in computing for the length of a confidence interval. Step 1. Identify the given variables. First, the upper limit and the lower limit. Second, standard deviation or the sigma or the S. Sample mean or the X bar. Sample size or n. And the tabular value. Step 2. Compute for the length of the confidence interval L. Use the formula L is equal to upper limit minus lower limit. If the lower limit and the upper limit are given in the problem, while use L is equal to 2 multiplied to the quantity of z alpha half times sigma all over square root of n, or L is equal to 2 multiplied to the quantity of t sub alpha half and n minus 1 times sigma all over square root of n if both the lower limit and the upper limit are not given. Step 3. Interpret the result. Let's have an example. A survey studying the income of individuals in a certain municipality was conducted. If 90% confidence interval for the true mean income of individuals in a certain municipality is 14,765 and 15,235, or 14,765 is less than the mean is less than 15,235, compute for the length of the confidence interval. Let's have the solution. Step 1. Identify the given variables. We have the lower limit that is equal to 14,765, and we have the upper limit that is 15,235. Step 2. Compute for the length of the confidence interval L. Since the upper limit and the lower limit is given, we will use the formula L is equal to upper limit minus lower limit. That is, L is equal to 15,235 minus 14,765. That is your L is equal now to 470. Step 3. Interpret the result. Hence, the length of the 90% confidence interval between 14,765 pesos and 15,235 pesos is 470. Another example. A survey studying the income of individuals in a certain municipality was conducted. If 95% confidence interval for the true mean income of the individuals in a certain municipality is 14,720 and 15,280, or 14,720 is less than mean is less than 15,280, compute for the length of the confidence interval. We have the solution. Step 1. Identify the given variables. So we have the lower limit that is 14,720 and the upper limit is 15,280. Compute for the length of the confidence interval L. That is our step 2. Since the upper limit and the lower limit is given, we will use the formula L is equal to the upper limit and lower minus lower limit. Now we will now have L is equal to 15,280 minus 14,720. That is, L is equal to 560. Step 3. Interpret the result. Hence, the length of 95% confidence interval between 14,720 pesos and 15,280 pesos is 580. For this example, we have the same situation. The question is, how was the length of the confidence interval affected by the decrease in the confidence coefficient holding the other factors constant? Holding other factor constant, as a confidence coefficient decreases, the length of the interval becomes narrower and vice versa. In this case, a 90% confidence interval with a length of 470 is narrower than the 95% confidence interval with a length of 560. Example: the following were observed weights in kilograms of a random sample of 20 learners, assuming that the population standard deviation of the weights of all learners in the class is 9 kilograms. We have a table that is 40, 45, 46, 48, 48, 50, 55, 55, 56, 58, 50, 59, 60, 60, 62, 62, 64, 64, 65, and 66. Step 1. For our solution, identify the given variables. We have a population standard deviation that is sigma that is equal to 9. Our sample size is n that is equal to 20. Our sample mean is x bar that is unknown. So we will solve for the x bar. Having a formula of summation of all x divided by n. Our x bar now is equal to 40 plus 45 plus 46 plus 48 plus 48 plus 50 plus 55 plus 55 plus 56 plus 58 plus 50 plus 59 plus 60 plus 60 plus 62 plus 62 plus 64 plus 64 plus 65 plus 66 divided by 20. That is, x bar now is equal to 1121 divided by 20, that is equal to 56.05. Now, let's determine the appropriate Z alpha half at 99% confidence level. First is to find where is the 99% confidence level in our table and its corresponding Z alpha half value. At a 99% confidence level, the Z alpha half is equal to 2.576. For its step 2, compute for the length of the confidence interval L. Since the upper limit and the lower limit is not given, we will use the formula. L is equal to 2 multiplied to the quantity of Z alpha half multiplied to sigma divided by the square root of n. We will substitute the given, that is 2 multiplied to 2.576 multiplied to 9 all over square root of 20. Simplifying it, we will now have 2 multiplied to 5.18. And the product is 10.36. Step 3. Interpret the result. Since the length of 99% confidence interval is 10.36. Let's have the same example. For the question, compute for the length of 95% confidence interval for the true mean weight of the learners. Step 1. Identify the given variables. We have a population standard deviation that is sigma that is equal to 9. Our sample size is n that is equal to 20. Our sample mean, our x bar that is equal to 56.05. Let's determine the appropriate Z alpha half or the Z value of 95% confidence level. So using the table, we will look for the Z alpha half of the 95% confidence level, and that is 1.96. Step 2. Compute for the length of the confidence interval L. Since the upper limit and the lower limit is not given, we will use the formula L is equal to 2 multiplied to the quantity of Z alpha half multiplied to sigma divided by the square root of n. Let's substitute the given in the formula. We will now have 2 multiplied to 1.96 times 9 all over square root of 20. Simplifying it, we will now have L is equal to 2 multiplied to 3.94, and the product is 7.98. Let's interpret the result. Hence the 95% confidence interval, that is 7.88 rather. Let's have another example. The heights of 10 statistics and probability students in inches are given below. Compute for the length of the 98% confidence interval for the true mean height of all statistics and probability students. we have 61.8, 66.5, 67.4, 67.6, 68.5, 71.4, 72, 72.4, 74.7, and 78.1. For our solution, let's identify the given variables. Our sample size n, that is equal to 10. Our sample mean is unknown, so we will compute for the sample mean. Having a formula of summation of all your x divided by n. We will add all our data, that is 61.8, 66 plus 66.5 plus 67.4 plus 67.6 plus 68.5 plus 71.4 plus 72 plus 72.4 plus 74.7 plus 78.1 divided by 10. And that is equal to 700.4 divided by 10, that is equal to 70.04. Another, our standard deviation, that is still unknown. We will compute that in the next slide. We use the formula square root of summation of all x multiplied to x sub 1 minus x bar square divided by n minus 1. We will use of the table. We will make use of a table. So we have our first column, our data, that is your x, that is 61.8, 66.5, 67.4, 67.6, 68.5, 71.4, 72, 72.4, 74.7, and 78.1. The total number of our data is equal to 10. And our x bar, that is, we computed that already, we have 70.04 for our second column. For our third column, we will subtract our first column and the second column, that is 61.8 minus 70.04, that is equal to negative 8.21. Second line, that is 66.5 minus 70.04, that is equal to negative 3.4. Next is 67.4 minus 70.04, that is equal to negative 2.64. Next is 67.6 minus 70.04, that is equal to negative 2.44. So on and so forth. For the last column, that is our fourth column, we will square our third column, that is negative 8.21 squared, that is equal to 67.041. Next line, that is negative 3.4 squared, that is equal to 11.56. Third line, that is negative 2.64 squared, that is equal to 6.9696. Next line is negative 2.44 squared, that is equal to 5.9536. So on and so forth. We will add all the value in our fourth column. We will now have 192.1981. We will substitute that in our formula. For us to get our standard deviation, we will now have square root of 192.1989 divided by 10 minus 1. Simplifying it, we will now have square root of 192.1989 divided by 9. We'll now have square root of 21.3554. And our standard deviation now is 4.6212. Now, let's determine the confidence level and appropriate t sub alpha half and n minus 1, or that our t value. For the confidence level at 98%, we will compute for the alpha having a formula of alpha minus 1 minus CL, that is equal to 1 minus 0.98, that is equal to 0.02. Therefore, our alpha half, that is equal to 0.02 divided by 2, that is equal to 0.01. For our degree of freedom, we have a formula n minus 1, that is equal to 10 minus 1, that is equal to 9. Using the students T distribution table, our T sub 0.01 and 9, that is equal to 2.821. Step 2, compute for the length of the confidence interval L. Since the upper limit and the lower limit is not given, we will make use of the formula L is equal to 2 multiplied to the quantity of T alpha half and n minus 1 multiplied to S divided by the square root of n. Substitute the given. We will now have L is equal to 2 multiplied to 2.2821 multiplied to 4.6212 divided by the square root of 10. Simplifying it, we will now have 2 multiplied to 4.12. And the product is 8.24. For the result, the length of 98% confidence interval is 8.24. That's all for today's video lesson. If you have a question, clarification, don't hesitate to message me in my messenger account, that is Kim Francis Season 2 now. Till next video lesson, goodbye!